Hello, and welcome to Spilling the Tea. This is the podcast where we explore the stories behind the technology shaping the future of privacy. I am Lisa Loud from Secret Network, and I'll be your host today. So, this show is all about real world applications of confidential computing, of AI, and how they're being used to solve complex problems and protect data and unlock new possibilities. We're not just talking about theory, though. We are sharing the journeys, the challenges, the breakthroughs from builders on the front line. And today's guest is someone with a great vision for the future of how this is all making sense and how it will make sense in the future. Today, I'm delighted to introduce Hang Yin, the CTO of Phala, as my guest. Hang Yin is a co-founder and the CTO of Phala Network. Phala is a decentralized cloud computing platform, and Hang Yin's role includes overseeing the technical aspects of the project. He graduated from Fudan University. Welcome, Hang. Nice to see you.
Yeah, nice to be here. Super excited.
We seem to be ending up at the same events lately, which is cool. I guess we're on a similar track. But can you tell us a little bit about yourself and what you're interested in, what you want to talk about today?
Okay, of course. Happy to be here, and I'm Hang Yin, the co-founder, CTO of Phala Network. Phala Network is a pretty old project, actually. We started in 2018, 2019, and it has been like a 6-year journey so far. We started with a vision to eliminate the trust in decentralized network. So people have been talking about like a Web3. We're going to make everything available in Web2, in Web3, but in a more decentralized way without trusting any big entity like the cloud provider or Google or like Meta. But the problem becomes um, the blockchain is great. It's a great start point, but it doesn't solve everything. For example,
Right.
you cannot run very large backend on the blockchain, and you cannot deal with the privacy on the blockchain because everything is transparent and you can
Right.
trace everything. So how can we make blockchain a place where you can deploy the app that everyone is using in daily life? Then this is the initial problem we're trying to solve.
That's a
And
big
we come up
problem.
with a solution, which is trusted execution environment. This
Mhm.
is just a technology, but how can we apply this technology in Web3 to solve the real world problem is the real challenge to us. So we have been focusing on this for a long time, and it was quite a journey. And now we're very happy to see so many people are already building on TE technology. And this is like a very brief intro of my journey so far. And by the way, before I started this startup, I have been working in Google for 3 years. And when I was working in Google, that was a really fun journey. Basically, my responsibility is to build the spyware that check your everyday email whenever you use Gmail, because
Wow.
there's a whole pipeline to extract the useful information either for some convenience feature or just for us in the Google pipeline. So basically, all the email is already being processed. And we extract that and use that for some internal services. And another
Wow.
thing was, yeah, and another thing I work in Google was there was like a an effort to bring Google back to China because Google was Google already exited China very early days, but they try to bring Google back, and then the problem becomes there must be some kind of censorship applied in order to obey Chinese law. So I was actually responsible to create one of the backends to censor the search result, and that is really not something I enjoyed a lot. So
Mhm.
after like 3 years of development, I still think, okay, maybe I'm going to switch to something even better. So I jumped to the opside, right? So privacy enhancing technology, confidential
Yeah.
computing, or TEE. So this is the place where I think the future will happen.
That's amazing. What an amazing story. So let me ask you, do you use Gmail now?
Well, unfortunately, yes, I'm
Uh-huh.
still using that now. Uh,
Interesting.
Still, very good to use. But yeah, to
Yeah.
some point, I do think there will be a better solution for that.
Right. So let's talk about AI because obviously AI has taken over the world, and AI and confidential computing have a really big overlap in terms of utility. So just can you talk about the meaning of confidential AI? How is that done? And
Mhm.
what direction blockchain and AI are heading together?
Yeah, I think this is a great question. So, confidential AI is not actually something new. It's a combination of two technology. One is AI itself. People are very familiar with that. And another technology is confidential computing. So I think the more interesting question to ask here is that why like people are talking about confidential AI instead of just AI. I think the reason is that confidential computing is a technology to solve the privacy problem and also the trust
Mhm.
problem. This is
Right.
like a more deeper philosophy involved here. So and especially when dealing with AI, the core is data, right? So in the past, if you develop some software, you're pretty clear what is running in this software and what you give to the software. But now,
Mhm. Right.
now we have entered the AI era, and AI is trained with data, and basically AI is just like an outcome of data and the computation, and the data itself is super. Is a I mean the security of the data itself is a super hard problem because for example, if you give some data to the big company like Google, you have no idea what they are going to deal with your data. Like they can easily copy your data and use it for some places, and you have no idea how they are going to use it, and
Yeah.
there's no way to prove it. So privacy of data or security of data itself is inherently a way harder problem compared with all the other problem like computer security. So
Right.
and another aspect of AI is that AI is super powerful. In the past, you use some tool just to solve your one problem, and now you're using AI to solve almost all the problem. You give your user privacy data in to the AI, and you ask AI very sensitive questions, and then basically what you give to the AI can even be like can even be used to construct the digital twin of yourself. So AI is so powerful. How can we make sure AI is secure? So the answer is we need to combine some kind of privacy enhancing technology together with AI to make sure you can feel safe to share the
Right.
data with the AI, and you can be sure what is behind the AI, what kind of the data is used to train the AI. Can AI does the job as is promised to you, or is actually doing something malicious.
Mhm.
So all those problems are really important because in the future there will be it's pretty sure there will be more and more AI, and how can we make sure AI can be trusted, or even better, how can we establish the trust between human and AI? So
Right.
the answer is confidential AI.
So what are the steps? I guess we're not quite there today. We're not at a place where all the AI and all the LLMs we use are confidential, where our data is protected. What do you see as kind of the roadmap between here and a future where we have safe, protected AI?
Yeah, this is also a really amazing question. So, like during the CC summit, and Lisa, you were also there.
Mhm.
We actually talked with a lot of people, and it's pretty funny to me that for most of the people, when I ask them, "Do you think AI privacy is important?" and "Do you think there's a way to protect the privacy when using AI?" And I would say like a 99% of the time, the answer is, "Oh, I'm going to run AI locally."
Oh,
So, like
right.
run a very, very smaller AI on your local computer,
Right.
or if like you want a really powerful AI, then you are going to develop, deploy the AI in your
Mhm.
own data center or your
Own
own
data
office,
center,
your
right. On
on-premise deploy.
servers. Mhm.
Yeah, yeah, exactly.
Yeah, I
So
hear that a lot too. I spoke with someone just yesterday about medical data, and she wanted something that where she could use public models, but not deploy her own hardware, and
mhm,
not deploy it on her own hardware. And that's a difficult puzzle. So
mhm.
what's the solution?
Yeah, so I think in this setup it worked for some time. Like if you as an individual user, you deploy the AI model on your own computer. The problem is that you usually don't have a so powerful computer as
Right.
powerful as the server. So usually you can only use like a 7 billion smaller LLM, which is sometimes work, but most of the time you're not going to use it. And for a little bit more like a capable enterprise or business, they can do the on-premise deployment. But then there are still two problems. One is that the cost is super high.
Yes.
If you use OpenAI or like a cloud, you just use pay-as-you-go API, and it's really cheap because there's an infrastructure shared with all the users around the world. So the average cost is already reduced to a very optimal stage. But if you deploy everything on your own, two problems. One is you're going to buy the server. Server itself is super, super, super expensive, like 300K of the server for just a one box to run DeepSeek. And at the same time, you cannot use the full capability of the server, right? You use that on your working hour, but when you're sleeping, the server is idle. So that's why like the cost is always high. And I'm not even accounting like the people you're going to hire to maintain the servers. That's even another set of the cost. So combine all those problems, it's really difficult to have a low cost setup if you run all the model locally.
True.
And yeah, how to solve that problem? Of course, moving that to the cloud. But then you are going to trust the cloud, and you don't want to trust the cloud. Then the problem becomes: is it possible that we can get the benefit of both running the model on the cloud and also make it private? So that's sometimes I describe the solution as virtual on-premise deployment, which
Mhm.
means that now you can rent some TEE-enabled hardware where
Virtual on-premise deployment. Interesting.
yes, 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 because on-premise is very easy to understand by the average people. If I tell them, okay, there's a confidential computing and there's TEE, there's attestation, it's going to blow their mind. They're going to take a long time to understand
It's a
everything.
lot. Mhm.
Yeah. So I just feel like now we can describe, okay, if we run your
Right,
model
I
on the
see.
cloud
Yes.
and we enable the TE technology, it basically work as a firewall of trust. So there's a firewall between your data and the cloud provider so that you don't need to trust the cloud. Although the physical server is maintained by the cloud, but still it's your data, it's your software. The cloud has nothing to do with your proprietary data or privacy. So I found this is a really interesting way to describe that to the AI users. And this is also a very effective and efficient way to make your AI private. So that's what we call confidential AI.
Okay. Easy to understand and efficient to deploy.
Mhm.
Okay,
Yeah.
cool. Um, so can you just in layman's terms, just for everybody to understand, can you describe simplistically how remote attestations and the UI UX of remote attestations could change application development completely?
Yeah. So now we have been talking about confidential AI and how like you can benefit from that. Basically, uh, all the user experience is almost the same as before, but now you get the benefit of privacy enhancing technology so that nobody else can see your input or your output. But then the problem becomes, okay, now someone tell me I'm going to offer you the confidential computing for AI, confidential AI solutions. But how you can tell the difference? Like if this is a real confidential AI or it's not, like it's still AI running on AWS with the spyware, right? So the difference is that we need something to show that this is essentially running with the right setup and everything is already secure. So this is how the remote attestation come up. With TE, a very important technology is called remote attestation. And whenever you have deployed something into the TE hardware, it's a black box, but at the same time, it's unlike a black box because once you run that, the black box itself is going to produce a proof. And this is a cryptographic proof signed by the hardware. So nobody else in this world can even make a fake proof. And this proof contains a few things. First, this is your program running in this black box. So you can tell, okay, this is some hash that can link to my source code. So you can check, okay, this is your code. There's nothing malicious running, which is deployed in this environment. And the second one, the environment itself is very secure. So nobody except your code can access the data. So this actually involve another concept called Code's law, because now we're not going to trust anyone. The cloud is not trusted because cloud cannot see anything from this black box. Memory encrypted, communication encrypted, and
Mhm.
everything is running in this black box. And we're not going to trust even the model provider or the developer, because even the developer, they deploy this system and they can prove that I have no way to check your data. So for the user, you can be sure your data is end-to-end encrypted and is even encrypted while it's being used and processed by the model. There's no malicious guy to log your data or steal your data, save it somewhere, because everything is transparent. Although your data is in the black box, but how your data is used is transparent. And those are everything that can be proved by remote attestation. So you got this proof and you're good to go.
So, this proof that comes up, what does it look like? Do I need to look at a string of letters and numbers in order to understand what this means? Do I need to compare it with something? How do I know without being a computer, how do I know that this proof is valid?
Yeah, so that's a really deeper question, and usually, I would say like 90% of the people in this industry have never thought about that, because when we deploy some AI model in the confidential computing configuration, the problem is how can we convince the end user, and the end users are not like professors or secure auditors. They
Right,
have no way to tell like what does this number mean, what does this some random characters mean from the report. So actually the report looks like this. It's a report with a lot of fields, and all those fields are just some hex data, and
right.
you have no way to tell what it is unless we have a good tool to explain that. So just like now you're using a browser and you use the browser to connect to Google, and on the left top corner, you're going to see a green check to say, okay,
Mhm.
well, sometimes green check or sometimes a green lock, right? Right. That means that this connection is already secure. But now we're talking about compute. Compute is inherently more complex.
Right.
So, but we still need to give a few checks to the user so that they can be sure, okay, compute is secure, the software is exactly the number, the version I want to deploy. There's the connection between the TE and the user is secure so that nobody can tap into this connection.
Mhm.
Uh, and we want to show that on the place. So that's why recently us, Phala Network, as
Yeah.
well as some other partners, were trying to bring up something that's pretty similar to blockchain explore, where even you're not like a technical people, you can still search your transaction and make sure, okay, this transaction is confirmed on the blockchain. But on
Mhm.
the confidential AI part, we want to make a report to easily tell user, okay, this is the right hardware, this is the right software, this is the right encrypted communication. They don't need to understand all the detail. And in this tool, everything is presented in a very clear way. You can see all the detail, or you can just see the overview. You can also like try to hire some secure auditors to use this tool to tell you, okay, it indeed looks good. So
Mhm.
I think something like this will completely change how the confidential computing enabled service uh, look like in front
Yeah.
of the end user and tell people, okay, this is the real secure service, and that is not a secure service.
Right. What about the tool? How do you make sure that that tool is secure itself?
Yeah.
What if someone
So
attacks the tool?
yeah, I think that's pretty similar to how like we deal with uh, blockchain and the decentralized technology.
Mhm.
So just in case some of the audience may not be familiar with blockchain, blockchain is a technology where we don't trust anyone, like not the cloud provider, not the software developer, not like the any participant in this space. So sometimes I even tell people, okay, blockchain people are really paranoid. They don't trust anyone. But
Yeah.
that's also, yeah, another very good aspect is to say that on the blockchain space, we all embrace zero trust technology. So zero
Right.
trust means that we want to make sure every part in this system is inherently secure. It's
Mhm.
not by trusting anyone, because if you trust anyone, they can always betray you at some point. But if we
Mhm.
don't trust anyone, you want to make sure every part is secure by algorithm, by protocol design, or by the hardware design. So
Right.
this is why we call that don't trust but verify. And back to the original topic,
Mhm.
how can we make sure the verification tool itself is trustable? I think the only way to make sure is to make everything purely open source. Open source
Mhm.
implementation, open source standard, so that if you don't trust the deployment, you can clone the code and then deploy your own version, right?
Mhm.
So you can see the exact same result. This
Right.
is verified by yourself.
Mhm.
And to make it even deeper, you can even make sure every part when you're verifying all the evidences provided by a TE application, there's always the methodology. You can follow the methodology to run the verification by yourself. And there should be very clear explanation why you should verify it in this way, and
Mhm.
why um, this source code can be compiled to this binary. So there's a relationship between something you can verify and something is a little bit harder to verify.
Right.
So make sure everything is verifiable is the top goal of the design of such a system.
Yeah, makes sense. So, do you think what's the timeline that we can expect for confidential AI to be a real adopted thing that is the default for AI deployments?
Mhm. Yeah, I actually have a pretty optimistic estimation. But before I say my estimation, uh, last month I went to a more academic event called IC3. Uh, Dr. Dang Song, who is also, the one of the pioneer of the confidential AI space, what she predicted is that within 2 or 3 years, like 80% of the workload should move from the non-confidential cloud into the confidential cloud.
Wow.
Why? Because first, the technology is pretty mature.
Uh-huh.
That was not true in back in 2 years ago.
Right.
But for now, if you want to move something into the confidential computing environment, it's just a matter of a few minutes, because you don't need to change the codes. and the user experience is pretty much the same. And there's no performance overhead, like a 5%, almost nothing.
Mm.
So there's no barrier for that. So why not, right? So
Right.
for me, I think probably not as optimistic as Dongson, but I think maybe in 4 or 5 years,
Right.
especially for AI. All the AI workload should move to the confidential AI environment because AI itself is already like very hard to be proven. And without any help from the confidential compute technology, you really don't know how like the AI company deal with your privacy
Right,
data.
right.
And
Yeah,
even
like you started out by saying that in a software program, it's fairly easy to get security because it's bounded. It's running on a particular machine, and you give
Mhm.
all the inputs and you define all the behavior. But AI is much less defined. You give the inputs for the data, but then it does its own thing. Plus, it's much more powerful. So I think you're making the same point now, is that AI is so powerful that not having it secured is much more of an impact or potential danger. Is that right?
Yeah, sometimes I describe that kind of like a nuclear fusion. It's so powerful. It gives you unlimited amount of the power. But the problem is you want it to be controlled.
Right.
AI with the control, that's productivity uh, uh, tool. But AI without control, it can even destroy the world, like
Right.
nuclear bomb.
Yeah. Such power needs to be guided.
Yeah, exactly. So, when talking about that, I would think in the short term, most people care about is the privacy of input and output, and even maybe they care less about what is the AI running in this black box, because as long as they can test it, they can feel how good the model is. But actually, in the mid to long term, I do think it's also very important to make sure uh, the origin of the AI. I mean, how this AI is designed, how this AI is trained is also very important because people are more and more likely to trust the AI they are using in their daily life. And uh, now AI is writing a lot of code, like 60% of the code in Anthropic is written by the AI. How can you make sure the AI doesn't insert any backdoor or give you any like a fake feeling or false feeling of secure and confident, right?
Right.
So then
Right.
the problem becomes how can we make sure AI model itself is trustworthy? And then the next problem is we need to check the supply chain of the AI model. First, you have the AI model design and you have the data. You put the model and the data into some data center to train the model. And then you get the model and you inference serving user and serving AI agents. And then in this process, whenever you're dealing with data processing or training or inference, actually you always want to make sure everything is transparent. You don't want someone to insert some small backdoor or insert some malicious
Right.
training data into this process. So in this case, the best way to deal with that is still confidential AI. It's not just about inference. It's all about the entire process, the entire life cycle of AI model supply and the AI model supply chain.
So we're recording this at an interesting moment. It won't come out right away, but yesterday Grok 4 was released, and it's blown away a lot of the benchmarks that were previously there for AI models. Do you have any thoughts about? And you mentioned it's very important to know what training goes into the model. We've had some PR incidents where Grok did showed that the training that went into it was maybe not ideal. So, do you have any thoughts about where we're going in terms of power and Grok 4 is this the right direction for us to be going, or are we going to have a course correction?
Yeah. Um, Actually, I didn't got the time to check what Grok 4 feel like, but I have heard about a lot about the concerns over model training data, because model itself is defined by the training data, and there are a lot of problem of training data. Of course, first one is, um, are you sure that the training data is accurate, right? If you give some fake information as the training data, the more you give, the more the model will give user the fake data, and eventually affect the model quality, or even they may mislead their users to do
Yes.
something bad, right? Then to solve this problem, I believe it's very important to make sure the source of the training data can be always tracked back from the final model. So that's the data provenance problem. So far, I don't think there's any big enterprise trying to solve this problem.
Mhm.
Maybe for some like a conspiracy, I would like to play some conspiracy here, um, because even for the enterprise, they cannot tell you how they got the training data. Maybe some of the training data even come from some user privacy data. They didn't ask a permission from the user
Yeah.
to use those data, and they
Right.
don't want to reveal that to the public.
Mm.
But the problem becomes first, because the training data itself is a black box. So people don't know how this model is. And if at some point the model can be malicious to the user. And the
Mhm.
second one is there's also a lot of like um uh, um I would say problem in yeah, how do you call that, like a merit problem, right? Um because the user are the owner of the data, and they are using the user data for free. They can do that in this way because they can try to cover uh, you know um, what is the training data. So they don't make it transparent, because this is good for their own business, but it's not good for the humanity.
Right.
So because of that reason, I think eventually we're going to find a balance
Mm.
to both like have really good model, and the same time it should be the interest of everyone, not a single entity, but the humanity. So the way to do that is there are a lot of like interesting decentralized AI projects trying to solve that problem. They're trying to make sure all the data collected to train the model is transparent. So there's
Right.
data provenance,
Mhm.
and at the same time they can make sure this process cannot be manipulated,
Yeah.
because everything can be running in the TEE with the confidential computing technology, so there's no way to attack it.
Right.
And finally, you got the model and you serve the model, and this supply chain is secured, so you can be sure nobody can do anything malicious here.
That is a great way to wrap up. Do you have any final thoughts to share, with our audience about, life in general, or AI, or Phala?
Yeah, I think a good way to close this conversation is some prediction about the future. So I
Mm.
would say, as we already discussed, I think like in 4 or 5 years, all the AI should run with the confidential model enabled by default, because that's the only way to guarantee we can align the interest of everyone involving in this in the UI use case, including like data provider, model provider, the users, right? And for confidential computing, I think it will be just more and more powerful. In the past, we have seen Intel SGX, the first generation of the TEE, is very powerful in terms of the feature perspective, but performance and the developer experience is not that good. But now we have the second generation, we have the confidential virtual machine code you don't need to change the code. It just run as is. So save a lot of time, and that's why we see a lot of real world use cases starting to onboard computational computing. And the same time we see now we have not only the CPU TE but the GPU TE, so you can run big LLM in the TEE as well. And in the near future, I think just recently, NVIDIA has already launched their Blackwell. And in Blackwell, you can not only enable the confidential computing for a single server, but the entire data center. So you can convert the entire data center
Amazing.
into like a big supercomputer with the confidential computing enabled. So that would be huge because then we can train AI model, even like a frontier model in TE, and then we can serve that with
That's a game changer. Yeah.
yeah. So yeah, I would say computational computing will be more and more powerful and more and more accessible. So yeah, I didn't see any reason preventing people to completely switch to computational
Amazing.
computing.
I love that vision of the future. Well, Hung and I are both heading over to MIT next week to talk about the Internet of Agents with Nanda at MIT. So look forward to seeing you there. And next time we meet, we'll have more to talk about. Thank you for joining us.
Thank you. Really nice talking here.